Okay, so we're starting with the leading coefficient test. In this, we are looking for the left and right-handedness of the graph. So what we do is first we look at the first exponent, which is a 5. This is an odd number. Therefore, the graph, the sides of the graph will be opening opposite of each other, like that. So next, now that we have our basic graph, we look at the leading coefficient. It is a -1. When it's negative, the graph flips over the x-axis. So now we have it like this. Now we just look at the graph. As x goes to infinity, terrible infinity. As x goes to infinity, y goes to negative infinity. No infinities today. And then, yeah, okay, so as x goes to negative infinity, right here, y goes to infinity. So that is that answer for leading coefficients. Next, we're doing Descartes' rule of signs. In Descartes' rule of signs, we are looking for the number of real zeros in this equation. So first we look at the number of sign changes. So we have one sign change from -7x to +10x. That means that there's one positive 0. Now to find the amount of negative zeros, we plug in -x. So now we simplify. -x to the 5th will keep the x as negative. So we change this to a positive. So we have 3x to the 5th. Same applies to the cubed. So we have plus 3x cubed. The squared, however, will get rid of the negative sign here and make it back to a positive x. So -7x squared stays the same. 10 times -x is -10x. And the constant stays the same. Now we check for the sign changes. We have 1 and 2. So there are 2 negative zeros. But because the zeros come in pairs, there could also be no negative zeros. So we have 2 or 0 or 0 negative zeros. I'm just going to kind of read sideways there. So 2 or 0. And that's it for Descartes. Finally, we're doing the rational zeros test. In this, we are looking for p over q, where p is the constant and q is the leading coefficient. Okay, so the constant is 4, the leading coefficient is -3. Now we find all the factors of both p and q. So now we simplify this into fractions. Yeah. So we have plus or minus 4 over 3, plus or minus 2 over 3, plus or minus 1 over 3, and then 2 over 1 is 2. Might just start with 2. 4 over 1 is 4, and 1 over 1 is 1. Kind of did that out of order. And these are all of our possible zeros for the rational zeros test.